My dear students, Assalamu alaikum. In last lecture, we finished the chapter kinematics, and now we are going to start the new chapter series. In this chapter, first of all, we will study about Pascal triangle. This Pascal triangle we are using to expand the binomial series. First of all, I will discuss here what is binomial series or what is binomial expression. The word binomial mean two terms. Word binomial mean two terms. You already familiar with the kinds of the algebraic expression. Is in algebraic expression. An algebraic expression having one term is called monomial. Having one term is called monomial. An algebraic expression having two terms is called binomial. An algebraic expression having three terms is called trinomial. All these are the kinds of the polynomial. This having one term, two terms, and three terms. All are polynomial. You are familiar with these type of terms, a plus b. A is here two terms in this one. This is the binomial expression. We cannot expand it further. If we are taking here a plus b whole square, you familiar with this one. When we will expand this one, here will be a square plus 2ab plus b square. This you studied in algebraic identities. Here, how we can expand this one? Okay, that in the lower grades, you are studying like this, that a plus b into a plus b will multiply, we are getting this one. But here as we want to use, as here in the topic also, Pascal triangle, we will use the Pascal triangle here. And how we can use the Pascal triangle? First of all, I'm expressing this thing here. In all the terms, here three terms, 1, 2, and 3 terms are here. In all the terms, we will write AB. Here AB. Here in the second term also AB. And in at the place of third term also, we will write AB. After that, what we will do? As here is square, then we will write at A, here the exponent of A square, and b raised to the power 0 we will write. Okay. Then now power of A gradually decrease by 1 and power of B gradually increase by 1. As A here 2, here will be power 1 and here is 0. In the same way, B raised to the power 0, here will be B raised to the power 1 and here will be B square. Now you can see a square into b raised to the power 0 will be a square. Same thing will be here. Here a raised to the power 1, b raised to the power 1 is ab, this and this one. Here a raised to the power 0, b square will be only b square, this one. We are getting same terms, but this 2 we did not get here. This 2 is here. This 2 is called the coefficient of this term. As here coefficient of this term, here nothing mean 1. Here coefficient of this term is 1. Here coefficient of this term is 2. And here coefficient of this term is also 1. How we can get these coefficients? these coefficients we are getting with the help of Pascal triangle. Here, one more example I'm giving you here. If you are writing a plus b whole cube, algebraic identity cube, a plus b whole cube, this will be equal to a cube plus 3a square b plus 3a b square plus b cube. Now here, same thing we will write. The first term ab, in the second term also here will be ab. At the place of third term also will be ab, and at the place of last term also will be ab here. Then after that, as starting from cube, as here degree is 3, we will start from 3 here. A cube b raised to the power 0. Now exponent of a gradually decrease by 1. 3, then here will be 2, here will be 1, and here will be 0. And b raised to the power 0 will increase by 1. Here power 1, here will be square, here is cube. Now you can see easily a cube b raised to the power 0 will be a cube. Here this a square as it is, b raised to the power 1 as it is, a raised to the power 1 as it is, b square as it is, a raised to the power 0 will be 1. 1 into b cube is b cube. Same thing. Only exponents are, coefficients are remaining. Here coefficient is 1, here coefficient is 3, here coefficient is again 3, and here coefficient is 1. But how we can get these coefficients, this we will learn here with the help of Pascal triangle. Okay, now I'm explaining here that how we can get with the help of Pascal triangle these coefficients. Here we will make one pattern. Now you can see here, when there will be a plus b raised to the power 1, then no need to expand this one. Okay, then a plus b whole square you can take, then a plus b whole cube, and a plus b raised to the power 4 up to this we are writing here. Okay, now a plus b, here we can write raised to the power 1. Here we can start from 0, a plus b raised to the power 0. Okay, when a plus b raised to the power 1, there will be two terms. Okay, one is a, one is b. A is having coefficient 1 and b also having coefficient 1. A is having coefficient 1, b is also having coefficient 1. When only one term will be there, that term is having here also coefficient 1. Now when a plus b all square, look here square is here, here we are getting 3 terms, 1, 2 and 3, 3 terms in the square. We are getting here 3 terms. In those 3 terms, 3 coefficients should be there. First and the last coefficient will be 1. In the middle, how we can write that I will explain to you. A plus b all cube, this one. Here we are having 4 terms, 1, 2, 3, 4. Then first term coefficient will be 1 and the coefficient of last term also 1. When a plus b raised to the power 4, then total number of terms will be 5 there. Okay, as here when exponent is 1, power is 1, then 2 terms, here power is 2, then 3 terms, power is 3, 4 terms, power is 4, 5 terms. then coefficient of first term and the coefficient of last term will be 1. In the middle, how we can get? Add these two, 1 plus 1, 2, you can write here. Now you can see 1, 2, 3, these three terms. Here add these two, 1 plus 2, 3, you can write here in the middle of these two, 2 plus 1, 3, here in the middle you can write 1 plus 3 is 4, 4 you can write here in the middle of these two, 3 plus 3, 6, and 3 plus 1, 4. Okay, in this way, if a plus b raised to the power 5 you will get, then what you will do here, first and the last term coefficient you can write 1, and in the middle you can get in the same way when you will add upper 2 and write the sum in between these two terms here in the lower series. Now you can check here a plus b all square. First term is having coefficient 1, then 2, then again 1. A plus b all square. Look, this one. First term coefficient 1, then 2, then again 1. Here a plus b all cube. First term coefficient is 1, then 3, then 3, then 1. Here 1, 3, 3, and 1. In this way, you can get coefficients of any one of binomial expansion. This Pascal, this triangle you can use to get the coefficient of any expansion. Now here you can see this triangle. This is the same triangle as I prepared now. Here, this one. First and the last term coefficient 1, 1, 1. And here, if a plus b raised to the power 0, then coefficient you can write here 1. Okay. And here will be 1, 1, 1, 2, 1, 1, 3, 3, 1. This is for square. Okay. This is for square a plus b square. This is for cube. This is when n is equal to 4. Mean a plus b raised to the power 4, a raised to plus b raised to the power 5. Now, question here is, when a plus b raised to the power n will be there, then what we will do? When a plus b raised to the power n will be there. That I will explain here. You studied about this, that a plus b raised to the power 1 or a plus b square or a plus b whole cube. In the same way, if a plus b raised to the power n, we will use the same way. As I told you, in all the terms we will write ab, here also ab plus again ab, then plus again ab in the same way. Now here, as power here is n, degree n, we will start the exponent from n and decrease gradually by 1. Here will be n minus 1, here will be n minus 2, here will be n minus 3, and so on. The same way, a raised to the power n minus r, this we will use for the middle term. Then b raised to the power r, we will take how we will take this. I'm explaining. Then up to so on. The last term we will get here n minus n. N minus n mean 0. You know, at the end was a raised to the power 0. Start from n and decreasing till be up to 0. Then here will be b raised to the power 0 and will increase gradually by 1. B raised to the power 1 here. Then here will be b square. Here will be b cube. And so on. Here will be a raised to the power n minus r, b raised to the power r. This, we can say, the general term or the middle term. And at the end, b raised to the power n, start from 0, 1, 2, 3 up to n. This is the last term of binomial expansion. Now, one question is here that what will be the coefficients? Coefficients will be here NC0. This C is for combination. Okay, you already studied in permutation combination, that chapter. Okay, this C stand for combination. Okay, NCR. You studied this formula. NCR. A raised to the power. Here will be n factorial over r factorial into n minus r whole factorial. R from the calculator directly you can substitute the value here. Okay, and with the help of Pascal triangle also. Suppose this is up to 5, then from Pascal triangle for n is equal to 5, you can get binomial expansions. Okay, now is from here a plus b raised to the power 5 you are getting, then up to 5 minus 5 you can expand this one. Okay, now NC0, here will be NC1, here will be the coefficient NC2, here will be NC3, and so on. Here NCR, and at the end will be NCN. This is the binomial formula to expand the binomial series.